Okay, so here we're looking at the following integral. We have sine x from 0 to infinity. And for these questions, what we're looking at is to determine if the integral, the improper integral, is convergent or divergent. And then if it's convergent, we can find its value. If it's divergent, that means our limit did not exist, and so there is no value to find. So we're going to be introducing then our parameter t. So we do integral from 0 to t sine x. And then all we'll have to do afterwards is the limit as t approaches positive infinity. So that shouldn't be too bad. We leave the limit for the end. And we deal with everything else. We do the antiderivative of sine x, which is going to give us negative cos x. And then we want to evaluate that from 0 to t. So we can plug everything in. We get limit as t approaches infinity. We get negative cos of t minus cos of 0. And when we look at this, cos of 0 we know is going to be 1, so this is actually going to give us minus 1. Okay, so we get a minus 1, however, it's going to be also having this negative right here. So we will end up getting a double negative there. In addition to that, we still have this limit as t goes to infinity in front. And so this is what we're looking at. Now, here we have to think for a moment. This function, cos of t, as t approaches infinity, what happens to the value of our cos function? And you need to remember that cos is going to be oscillating. And so as t approaches infinity, this limit here is actually not going to exist. It's not going to be approaching positive 1 or negative 1. That limit is just going to be dne. And so as we've seen before, if that limit does not exist, then this integral is going to be divergent.